So always remember when combustion is given, like in the question, if you have a combustion, it should be a reactant minus product, and a formation is given product minus reactant. So because which expression gives the standard enthalpy change of formation of a methanol? So first we have to write the equation for formation of methanol. Carbon, hydrogen, and oxygen, when they react, they will form a methanol. So this is a equation for, so we have this reactant and we have a product. So, and the combustion is given, all the combustions are given. So whenever combustions are given, it's CRP, not CPR, because I also got confused with this. So it is CRP. And when a formation is given, it is product minus reactant. So we write an equation for formation, and then because this is a reactant, so combustion of a carbon, the first equation is a combustion of carbon, 394, and the hydrogen is also there. 1 mole is minus 286, but there are 2 moles are burned, so it will be minus 286 times 2. Minus CH3OH, that is the combustion of methanol, which is minus 726. So this is the equation which is formed. So which one it match with? It matches with option C. Is it clear? Question 8, any doubt? Okay. In question 8, how many moles of iron to ethane diode react with 1 mole of a potassium manganate? So this is a formula is given. So first, what should be the total combined equation for this iron 2 and ethane diode? When I combine the equation, I will add these two because I should know their total equation. So the combined equation will be Fe2 plus and C2O4 with a charge -2 gives Fe3 plus 2 CO2 plus 3 electrons. That's a combined, because we want the reaction between acidified potassium manganate and iron 2 ethane diode. And in iron 2 ethane diode, both of them tend to lose electron. So this is a total equation of these two together when they lose electron. The same compound contain two ions which have both tendency to lose electron. And we want to react with potassium manganate, this equation. So this is our equation 1 and this is another equation. So we want to write a balance equation, combine the two equations because we want to find how many moles of iron 2 ethane diode react. Because when they combine, this will be FeC2O4 will give Fe plus 3 plus 2 CO2 plus 3E. That's the equation. So whenever we want to combine the two equations, we make the number of electrons same. Here we have 5 electrons and here we have 3 electrons. So how I can make the number of electrons same? If I multiply this equation by 3 and I multiply this equation by 5. So the number of electrons will be same, and then I will add the two equations. So this will be 5, 5, this will be 10, and this will be 15. This will be 3, 3 multiplied by 24, this will be 15, this will be 3, and this will be 12. So when I combine these two equations, so it will be 3MnO4 plus 24 protons. Electron will cancel with electron, plus 5 FeC2O4 gives 3Mn plus 2 plus 12 water molecules plus 5 Fe plus 3 plus 10 CO2. That's the combined equation. And the question was one mole of potassium manganate, how many moles of iron 2 ethane diuret are needed? So ratio is 3 is to 5. Like 3 moles reacting with 5. So if I have 1 mole, how many moles will be there? X. Because the ratio between potassium manganate and the iron 2 ethane diuret, 1 is 3 is to 5. So if I have 1 mole, how many moles should be there? X, cross multiply. So it will be 5 divided by 3. So 5 divided by 3, it is 1.67. So 1.67, so B should be the right answer. Is it clear, this one? Question 9, 10, any doubt? Question 11, any doubt? 11, 12. Question 11 or 12, any doubt? Question 13, 14. Any doubt? Question 14. Okay. Question 14. Which properties of anion result most easily polarizable? Polarized. The term polarized means, like example, if we have the distortion in the negative ion, that is called polarization. The anion. So this is a cation. The positive ion move towards cathode. This is the anion. So when we talk about the size of the anion, the size of the anion should be large as possible. Because when the size is large as possible, so it will experience a greater distortion. And the charge of the anion should also be large because, see, if I say there are 11 electrons and 10 protons, so the net charge is -1. But if there are 12 electrons and 10, if there are 12 electrons and 9 protons, so what will be the charge? The charge will be -3. Or if I say 11 electrons, so the charge will be -2. So negative, so the attraction of the electrons will be greater towards the positive ion. So as a result, distortion will be more. So if you want a large distortion, greater polarization, the size of the negative ion should be large and the charge of the negative ion should also be large. So A should be the right answer. Because if the difference in electron and proton is more electrons are shifted away. So the large charge means that there's a large difference between the proton and electron, or proton are not able to attract the electron easily. So as a result, it will cause a greater distortion. Why does high melting point than NaCl? Look, melting point depends on the strength. The melting point, like example, when I say sodium fluoride, distortion is the polarization effect. The polarization effect, the calculated value of a lattice energy and the theoretical value of a lattice energy. Like sodium ion and we have a fluoride ion. So and we have a sodium ion and we have a chloride ion. Which one I expect to have a high lattice energy or a high melting point? So the lattice energy of a sodium fluoride will be like -700, but for sodium chloride, the lattice energy will be minus, say 600 or -400. Why the lattice energy of a sodium chloride is less as compared to sodium fluoride? Because it is smaller in size, so they have a large attraction. But when I compare the theoretical and the practical lattice energy, in sodium fluoride, there will be less distortion. So the practical lattice energy and the theoretical lattice energy, like practical lattice energy might be say 712 and the theoretical is 700. But when I talk about the lattice energy of a sodium chloride, it will have a greater distortion. So as a result, As a result, what will happen? The lattice energy difference will be greater. Like theoretical lattice energy is minus 400, but the practical lattice energy might be minus 450. So it won't be higher than sodium fluoride, but the distortion or the polarization cause a difference in the lattice energy, theoretical and the practical. So when the size of the ion is greater and the charge of the negative ion is greater, there will be a large difference in the theoretical and the practical lattice energies. Is it clear? So the polarization affects the lattice energy, but the lattice energy depends on the size. It should be smaller. And which cause a greater polarization? For cation, the size should be small, so they can attract the electron easily, and the charge should be large, so they can cause a greater polarization. So polarization for the cation, small size, large charge. Polarization of the N, cation does not polarize. Cation cause the polarization. So polarization power of the cation depends on the size, small, charge, large. And polarization of anion depends on the large size and large charge. So this was a pop quiz. Inshallah, next session we'll discuss the structure pop quiz as well as the weekly homework doubts. Any question or doubt related to the class today? So I'll end the session and share the related recording.